Welcome to Physics 231, Lab 10, Lenses and Faraday's Laws. The setup for this week's lab isn't too bad. It's an oscilloscope, a variable gap magnet, and a snatch coil, which is really just a 2 centimeter in diameter coil of 10 loops. And what we do is we hook it up to the oscilloscope and change the settings. The large yellow knob will change the voltage per division, and the large gray knob will change the time per division. And we set it up in such a way that the scale makes our peaks easy to see. And then we hit run stop, which is the glowing red button. And then we hit single when we're ready. And we pull the snatch coil out. And so you can see that that peak isn't on the screen anymore, and that's because this takes data over longer than just one screen shows. And you can scroll side to side until you find, hopefully, the peak that is made by snatching the coil out. And so what happens is you have your coil in a magnetic field produced by the snatch or the variable gap magnet, and when you pull it out, the field through the coil goes to 0, and as you may remember, coils, solenoids, that type of thing oppose that change, and so an EMF is induced to produce a coil or a magnetic field to oppose that change, to try to maintain the status quo. And so what we see on the screen is the EMF produced by snatching the coil out of the variable gap magnet. And so for today, what we're going to do is compare one quickly snatched out, which is the sharp peak that you see before you, and one that is snatched slower, which will have a more broad peak. You'll receive a picture of the oscilloscope screen for each of these, and you'll be using those to kind of analyze the data and figure out what the magnetic field is for the magnet itself.